Hello everyone, this is Aditya Gupta and I'm going to present the IFT 530 Advanced Database Management System project. The name of the team is the Golden Trio and the members are Aditya Gupta, Ashwini Ragit and Kourosh Sharifzadeh. Okay, so the project is Inventory Management System. It's the database which is almost similar to any database in Walmart or any other supermarket. So, talking about our project, there's the table of contents, and we're gonna start with the abstracts of the project. This database project proposal is for the final project in the Enterprise Data Management System course, and focus on creating a back-end database for an inventory management system in retail, physical and online retail store and with an approach on the grocery items. So basically we are creating the database, back-end database for any departmental store or basically supermarket to handle all the queries and the database, its inventory details, its product details, their customer details, and the daily transactions that take place. So the main key part is that we are using the EAN, which is a unique barcode assigned to each product and which is unique all over the world. So it's a universally unique code which is used to identify any particular product. So this is the primary key that we are using to identify our product in database. So as we have already told that database is one of the most crucial part of any departmental store or superstore. Uh, with database, they are able to handle all their data, information about their product, their sale, their salary, and their customers in very correct and neat form, so that they can use it in future for their benefit. So keeping all the database is one of the main part of any departmental store, as if you keep that, your departmental operations will be very smooth in your daily life. So in any chain management system, it is one of the most crucial part, and keeping the database neat and clean and fast and responsive and up to according to your need is just going to save a lot of trouble in your daily work. So talking about the context settings, we have taken a database from this and this website, that is Kaggle website, and from there we have extracted the details of all the product that we have and divided it into basically two tables, that is one inventory table and one is product table. So in product table, we have directly taken the data from these websites, and for the inventory part, we have modulate the quantities and the settings according to our table. Sorry for that. So moving on, uh, the relationship between the entities and table are as follows. I mean, from customer to transaction table, it is one to many. From customer to return item table, it's one to many. Same with employees to transaction table. and employees to return item table, transaction to return item table, it's one to many, from transaction table to products table, it's one to many, but from product to inventory table, it's many to one, and from product to return item table, it's one to one. So talking about the non-relational database, as we know that non-relational database is a kind of database that doesn't follow the relational model provided by a traditional relational database management system. So it doesn't follow any relational approaches that a normal SQL database follow. And the benefit of the NoSQL is that it is more adapt in scalability part, more adaptable and more flexible in storing the data. These are the data and the entities and the constraints that we have used in our data table. For product data, that is the product table, these are the columns that we have used. First is product name, product category, EAN, which is the barcode which we have used as a primary key, and SKU, stock keeping unit, and arriving date, expiration date, purchase date, sale price, and item weight. For the inventory table, the quantity table and the number of items in inventory. For transaction table, transaction ID and the total amount. Customer data, customer name, customer ID, gender, age, phone number, email, and email address. For the employee, it's name, ID, driving license number, address, phone number, email, gender, salary, and designation. And for the return item data table, the transaction ID, summation refund, mode of refund, time to return, constraint. In a product table, the constraint on product ID and its various entities is as follows. First, for product ID, it should be not null. SKU, it should be unique. Item number, not null. Category, not null. EAN is the primary key, and arriving date, expiration date, and purchase date, it should not be null. And again, sale price should not be null. Weight and vendor is optional. In inventory, the constraint is as follows. Inventory ID is used as the primary key. SKU, item name, category, EAN, quantity unit, number inventory, not null, arriving date, expiration date, not null, purchase price, sale price, weight, vendor. For the customer table, the primary key is customer ID, then customer name, gender, age, phone number, email, and address. It's all should not be null. Then in transaction table, the primary key is the transaction ID, the foreign key is customer ID, then EAN and employee ID, and the rest of the columns should not be null. In return item record, the primary key is return ID, the foreign key is transaction ID, customer ID, and EAN, and employee ID, and rest of the things should not be null. And in employee table, the primary key is employee ID, and the rest of the column should not have any null value in it. Now, moving on to the conceptual model diagram. Okay, so this is our conceptual model diagram for our database. The column that is highlighted with blue is our primary key, and the one which is highlighted with green is our foreign key. This is the logical diagram. Okay, moving on to the query part. We have formulated around 20 queries for our database to display all the customers, select all from customer table. It is fairly simple. Next, to calculate the name of a maximum product refunded. I mean, the product that has been refunded for the max. This is our query. We're gonna select the top one, that is the EAN number from the return item table by grouping up the RTEAN. So this way, there is a table going to be formed grouped up by the EAN number, and the first row will have the maximum number of EANs. So that's why I just written top one, so that whatever the EAN number will be at the first will have the maximum number. So automatically it's gonna return the EAN number of that product which is maximum. Then we're gonna match this EAN number with the product uh, EAN column, so that we can extract the details, that is product name, from the product table. This is the screenshot and this is the result. Now the storage table. So in storage table, the storage table that we have created is for the finding the overall profit between any two particular dates. So first we have created two variables, D1 and D2, which is going to take the first date and the second date. And let me just correct it. Okay. What we have done is gonna uh, first uh, okay uh, is gonna select the value of total sum subtracted by the purchase price into the item quantity as profit from transaction table. We have basically joined the two tables, transaction table and the product table, on the value on the column EAN from both the tables, in such a way that the timestamp for the transaction table, that is the time period for or the exact timestamp of when a transaction has taken place. So that time is compared between D1 and D2, and accordingly it will return or sort out the temporary table which will have all the transaction or the product that has taken place between those two dates. Alright, so the next storage procedure is to calculate the purchase history of any particular customer. For that, we have created a stored procedure called sp underscore customer. It has a one variable that is at the rate id. It's gonna simply search in the transaction table for the customer ID with the ID number that has passed to this procedure table, and it's just gonna return all the details, or sorry, just gonna print all the details of the transaction placed by that customer one by one. This is the detail. This is the storage procedure, and this is the output of that. Next is the functions. So in this, we are searching employee detail by employee ID. So we are passing an employee ID to the function, and it's just gonna return the employee details. As you can see, we select everything from employee details and passing the employee email ID. It's gonna compare the email ID that we have passed with the email ID column in the employee ID, and it's gonna return its all of its attributes. This is the output. Next is we're gonna search customer details by customer ID. The procedure is almost same. We're gonna pass the customer ID from this statement, and it's gonna get stored in the variable CUSID, and it's gonna return the customer details or all of its attribute from a customer table, matching with the condition that the customer ID is equal to the past value. This is the output. Search transaction detail by transaction ID. So we're gonna, in this function now, we are just gonna pass the transaction ID to search the detail of that particular transaction. Similarly, we're gonna pass the transaction ID as usual. Then we're gonna create a function and store that pass value in at the rate ID. We're gonna match the transaction ID in the transaction table, and we're gonna select all its attribute and return it. This is the example output. Now the next function is searching the product details by EAN. Similarly, again, once again, we're gonna just pass the EAN number to this function and store this pass value in at the rate ID. It's gonna match the EAN with the past value in product table, and from that, once it is matched, it's gonna return all the attributes of that particular row. This is a sample example. Now the triggers. I've just created two triggers in this database. One is for transaction table. When there's gonna be any transaction, then there will be a changes in the inventory part. For example, if a customer has bought, let's just suppose product A, so its quantity, it's gonna be decrease from the inventory. Next, the next trigger that I have created is for the return item. When there is gonna any item that is gonna be returned in the departmental store, so that item will be added in the inventory. So that modification will be done in the inventory table. Next part is the NoSQL part. This is going to be explained by my other project partner, Kourosh. But before that, I'm going to run all the queries one by one